There's 6 students in one group. Okay, so number one. Number one's in standard form. So I know let's find the x value of the vertex. I want to use negative b over 2x. So that would be negative 12 over 2 times negative 2, which reduces down to 3. So my x value is 3. I need to find my y value. Well, anytime you have an x value, you're going to find a y value, just plug that x value in. I would definitely use my calculator for that, and I would do negative 2 open parentheses times 3 squared plus 12 times 3 minus 15. I type all that out, making sure I use parentheses correctly into my calculator. I already know the answer. I did this earlier. So that's the vertex of my parabola. So I go to 3, 3, and I put it down. So now I'm looking at my quadratic in standard form, and I notice that it's a negative 2, which means my parabola is going to open down. From there, I just need to take one more point on my x-axis, plug that point in, and get my y value, and then I can reflect that point. So I'm just going to plug in 2. So instead of a 3 here, I'm just going to put a 2 in. Once again, please use the calculator. All right, it's there. It's going to be there for your test. When you plug 2 in, you end up getting 2 comma positive 1. And then what can I do with that point? What can I do with 2 comma 1 to get my shape of my parabola? What do I do with 2 comma 1? Yeah, Robbie? Yeah, reflect it over. I connect my point, and I have my parabola. Anna, what's up? When I plug 2 into this equation that's down here, I get negative 2 times 4 is negative 12, plus 24 minus 15. Yeah. Oh, what's up? Any, what? You can plug in any number that you want. I recommend plugging in 2 because it's right there. It's an easy one to plug in. James? Which formula? Yeah, that's a great thing to have on the board. That one's just, yeah, that's a great thing to have on the board. All right, so going on the board is negative b over 2x. Now, it's your job to know that that's how you find the x value of the vertex. You plug that in. If you want to be really fancy, I can put this up for you. That'd be the whole thing, right? This is how you find the x value, and then you shove that x value into the function to get the y value. We can be really fancy. There you go. We'll be really fancy. And that still can only count as 1. It won't count as 2. Okay, so that, Michelle, is how you approach the problem. Any more questions on numbers 1 or 2? Okay? In this case, I can say like what I told Anna, when you're asked to find them, they're very easy to find. If you got one like this, I would just estimate 4.1 comma 0 and 1.9 comma 0. Is that a math related question, Rob? Oh. All right, how about questions 3 and 4? What questions do you have on numbers 3 and 4? Do you want an exam? Do you want one? No. Oh. Questions 3 and 4. We're graphing those. Viva. Well, what about number 3? No. Are you guys all right over there? You're very distracted. You need something. There's something wrong. Okay. All right. With Eva, why is it not an absolute value function? So there's no absolute value. Correct. So what kind of function is it? Quadratic. Yeah, it's a quadratic in vertex form. The quadratic and vertex form. So then what question do you have about it? Yeah. Okay, so if this is in vertex form, that means that my vertex is at the opposite of this value, comma that value. So it's at -2, comma -3. And then from there, Madiba, all you're going to do is just pick another x value. Just like last time, I'm choosing -1 because I think it's easier, but you can choose whatever you want. Alright, I'll pick something that's on this graph because this makes it easier. Generally, we pick something right next to the vertex so we get the correct shape. So when I plug -1 in, -1 plus 2 is +1. +1 squared is 1, and 1 minus -3 is negative. So I get to spot -1, comma -2. I reflect it over. Easy to try. Other questions on numbers 3 or 4? Other questions on numbers 3 or 4? Question number 5. Where would I start question number 5? What would be the first thing that you want to do with question number 5? Yeah, fill in B. Fill in B and notice it's a right triangle. Right? So you could use log signs if you wanted to. That would not be your best move, as you could just use regular tricks. Right? So to solve for x and y, so Madiba correctly said to get B, you just do 90 minus 23.4. 66.6. And let's the dot there and the y. And then from there, I can just use the sine of 23.4 degrees equals x over 2.1, and the cosine of 23.4 degrees equals y over 2.1. Cross multiplying in there. Yeah. Sure, what's the other one? Yep. That was the sine. Michelle. Does anybody not want those if they think it's a waste of time handling something? This is as much as I'll put this up. Okay? I'll put that in. Well, look at the end of the class and see if anything else shows up. We'll give it a try. So I'll get you all your set. Wait, you just have the middle. Okay. So the two rules here are you can't have negative exponents, you can't have fractions in and out. You don't have to worry about fractions in and out. That's a non-issue for you. All right, what you do have to worry about is how to simplify these. So, as promised, I said I would review these in depth. So, when I see question number 6, I see a 3 and a 2. The first thing I'm going to write down is 6. So 3 times 2. Then I see I have a u to the first and a u to the fourth. So when I'm multiplying like bases, what do I do with the x? I'm multiplying like bases. I do line up with u to the fifth times b to the negative 2. Now I'm not allowed to have negative exponents, so what do I do with negative exponents? Yeah. So if it was in the denominator, it goes to the numerator, it becomes positive. If it's in the numerator, it goes to the denominator. Your final answer here is 6 u to the fifth over b to the positive. What do you do in question number 7? What do you do in question number 7? Oh. You write that down? No. question number 7. What should we do to simplify that first? Well, I was seeing it. You wanted to respond to the last one, so we should be. Yeah, you just switch it. So I get 3x to the 4th over 2y. No, you only switch things with a negative exponent attached. No, but I asked the question twice and I looked at you, so I was trying to get you to answer. But you were just very distracted by pressing the button. So, David? Sure. Can you tell the difference in all three of those? You can't? Alright, so here, the x and the negative 1 are connected. Here, the 3 and the negative 1 are connected. And here, the 3 and the x are connected. Yeah, whichever one the exponent is actually on. So in this case, it's on the x, so this is equal to 3 over x. Here it's on the 3, so that's x over 3. Here it's on both, so it's 1 over 3. These 4 rules that you pretty much need to know, you need to know that, a to the m times a to the n equals a to the m plus n. That a to the m divided by a to the n equals a to the m minus n. That a to the negative n equals 1 over a to the positive n. And that a to the n to the m equals a to the n times. You can have 1 in all. These are the ones that these are the big ones to know. Everything else is just a application. Oh, here's one thing. What's anything to the 0 power equal? 1. Remember this. Or that even Mr. Smiley to the 0 power is equal to 1. Alright, the raised to the 0 power is equal to 1. Alright, so does someone have an argument for which one of those should go on the board? I have an argument for which one. But I want to hear you. What? You can get one.
The third one. What about the first one?
Alright, can I get a vote for, we're voting on what I just wrote. Raise your hand if you want that on the board for your Alright, I guess, Anna, you're memorizing it, sorry. This is the one that should go on the board.
What?
Nah, the one that ruins everybody. There you go. I'll give you 2 for 1. Both ways. That's the one that ruins everybody's day. For whatever reason. I don't know why. But now you're going to reciprocal, right? No, it's safe. And like I said, I put up about 8 problems on it. Okay, numbers 8 and 9. What questions do you have on numbers 8 and 9? Numbers 8 and 9. How to do it? Well, Miles, it says to solve. How do we solve things? We get variables by itself. Oh, you're doing the whole thing now. So what's your first step in number 8? Alright, so I get x squared equals -1. What's the next thing that I should do? I guess the question I ask you is, what's the inverse operation of squaring? Catherine? Square rooting. So x equals, what is the square root of -1 equals? Plus or minus? Oh yeah. So that's solution set notation, generally speaking, so we do put things in that. There was another question that I missed. Yes, sir? No, I squared is equal to negative 1. So I is equal to the square root of negative. Same thing for number 9. The only time you can solve by square root is when you have no b value. You can solve by square roots when you have no b. What? You add, divide by 2, and square root. Any other questions on 8 and 9? Okay. Solve each equation with the quadratic formula. The first hour already asked the quadratic formula. I'm sure most of you could have probably pulled it out of your head to the answer. What's the first thing, though, to be able to use the quadratic formula? What do you have to do with your quadratic equation? Go ahead, Ben. You got to put it in standard form. So here I get 3m squared plus 7m plus 4 equals 0. Now that it's in standard form, I can actually use the quadratic formula, which will be in. So I get the opposite of b plus or minus the square root of b squared, that's 49, minus 4 times a, that's 12, times c, that's 48, all over 2 times a. Then with negative 7 plus or minus, well, 49 minus 48 is 1. And the square root of 1 is 1 over. This is where I apparently failed this year at teaching this well enough. What's the next step? How you actually get your answer? Michelle? That's how you get your 2 answers. Is that with the shot, Richard, or is that? Oh! Shot fired. All right. Scale what's up? It does not. It does not. Nope. Oh. Fatima. She got like 0.08 or 1.2. Is it calculating degrees or radians? Degrees? I'm not sure what you're doing with wrong. Yep. So you do. Is that not the right answer? I would trust the trig over your ability to look Pythagorean theorem correctly. Yeah. I guess the question is should I use fractions or decimals? I can tell you that your exam is 49 questions long and 41 of them are multiple choice. So you should know that negative 4/3 and negative 1.33 are the same because you don't know what answer you're going to get. Right now? Any other questions on 10 or 11? Solve each equation by factoring. These were the extra questions that I just put up during II on Edmodo. If you need more help solving with factoring, well, we can start with just these 3. What questions do you have on these 3? Do them, that's the question? Is that it? Yeah. So all 3 of these present nice situations. So when you're factoring, what should always be the very first thing that you do? There's always something you do first. You do your 2 sets of first. You ask yourself, how do you get n squared? plus n times n. And I'm still finding you very distracted today. Is there something bothering you? What's going on? So, right, what I need you to do is you're in high school, you're a freshman. Don't do the classic freshman mistake of bombing your finals. Lots of people do it. Pay attention, please. Okay? It does. I'm telling you, even well-prepared students will bomb their finals. All right? So please pay attention. Focus these last couple days. I'm not really concerned about your math, though. I don't know about all your grades. But just, if you have a B, keep your B. Try and get an A. Don't be satisfied being like, I can get a 30% and still pass the class. That's what poor students do. Okay? All right. So the question is, do I multiply to the C value and add to the B value, or do I multiply to the B value and add to the C value? That's the only thing that causes anybody any type of frustration. Lindsay. Yeah, you add the B value and multiply to the C value. So it's going to be a positive 2 and a negative 5. Now, the big question, how do I go from factors to solution? How do I go from factors to solution? Connie? Yep, you do n plus 2 equals 0, so n equals negative 2. And you do n minus 5 equals 0, so n equals. Put them in solution presentation if you want to. That reminds me. On part of your final, there's a question bank. There's like an answer bank that you pull answers down from. We'll go over it more when you actually see your final. But, you know, this might be letter B, and this might be letter F. And so on your exam, you write B and F. But we'll talk about it when you actually see it. Excited? Well, it depends. I can tell you that part of the test asks you to factor, and you need to write the factor, and part of the test asks you to give the solution, and you need to give the solution. Well, 41 of the 49 questions. Yes, sir. To this? No, the sub just posted them. I did not put them on the list. I can't put them on it. Number 3 is a nice case to, or number 13 is a nice case to look at. How do you factor number 3? How do you factor, sorry, number 13? How do you factor number 13? What do you have to remember about question number 13? Megan? Is your hand up for a second? Okay. Zane, what do I have to remember about question number 13? No, Jake. You could solve by taking the square root. Thank you. Yeah. B equals 0. So you're going to say? So this turns into x squared plus 0x minus 9 equals 0. So this is x plus 3, x minus 3. You'll simplify. Oh my God. You can take it that way, or you can just laugh like how you did and enjoy it. I'd go for a 5. They're much better. Number 14. How is number 14 different? All three of these just have a little different thing I want to talk about it. Caleb, how's it different? All right, so we're already in standard form. Catherine, what's your thought? It has a 2. And more importantly, it has a 2 I can't factor out. So what changes inside my binomial? And Kylie, will you unplug the lamp, please? What changes inside my binomial? Yeah. It would be. At this point, I have my black factors. A lot of students just want to switch the second value and say your answers are -1 and 4. Right? That's wrong. It's -1/2 is 4. because 2b plus 1 equals 0, you subtract 1 and divide by 2. All right, so make sure you take that extra 3 seconds to get that question. Anyone need more time on the factoring page? Yeah. You think I just spent 7 minutes going over? Alright, so Naviva, I'm recording this. You can watch it later tonight. Yay! You have trouble with factoring, do more of the problems I put up on Emoto. You can always watch a little video, and I'd be more than happy to help you swing by sometime like after school. But just get your binomials built. Ask yourself, how do you get your first thing? And then list your factors for your second thing. Start guessing and checking. That's how we learned how to do it. That's the only way we learned how to do it. We didn't learn any seed tables. We didn't learn any weird things. That's a 3. 5 plus 3 doesn't equal 9. What?
Oh, wait,
Questions on 15 or 16? Questions on 15 or 16? The microphone's right here, so it does a really good job of getting me, and not an awesome job of getting y'all. They are going to give me a microphone for next year. I get to put it right up there, so they can actually hear what's going on. Because I've been told the videos it's difficult to hear my voice because the microphone's too bad. Which is too bad. I want it to be helpful. 15 or 16? Any questions on 15 or 16? Caleb. A little blue. 15 is not a function, correct? Because my input of 3 gives me both a -2 and a 7. Any questions? Declarations of confidence are nice as well. Michelle. Yep. Yeah. So if we were to grab our vertical line test right here, we can see that it passes the vertical line test, so it's a function. Did you have another comment, Caleb? 16 is a function. It does pass the vertical line test. Makes it 25% of test. Yeah, so you have the same inputs and outputs. If you keep putting 2 in and keep getting a 3 out, that's a good thing. That's what you want. Okay, so here you go. If I have my function and I put a 2 in and get a 3 out, and then put 2 in and get 3 out, and put 2 in and get 3 out, and put 2 in and get 3 out, that's good. I'm allowed to have that. What I can't have is I put a 2 in and get a 2 out. All of a sudden, it's not a function. All right, that's when it turns into not being a function. Now, I can put, so this is not a function. I can put a 2 in and get a 1 out. I can put a 3 in and get a 1 out. I can put a 4 in and get a 1 out. Those are all functions. It's as soon as you have the same input, like we have here, with different outputs. That's when it becomes efficient. How are we with interval notation for writing our domain and range, and our negative and positive infinities, and our brackets and our parentheses? Oh, we should ask that question. Mr. Children, how do I do the domain and range of a function? Oh, I don't know. Alright, so domain. All you want to do is ask yourself, does this function go on forever to the left? Yes. Open parentheses, negative infinity. Does this function go forever to the right? Yes. Positive infinity, close parentheses. All right, great. What is the lowest value that this function goes to? It goes to 2. What's different about the thing before it? Right. It's a bracket that includes 2. Does it go on forever to the very top? Yes. So we get a yes, sir.
For 15,
No, you just we just do this, and you list them. So your domain here would be 2, 3, negative 4. Your range would be 3, negative 2, 7. What do we do? Questions on 17. Harrison, how do you do number 17? You just plug the numbers. So 3 minus 1 squared, 2 minus 2 squared, 3 minus negative 6 squared. That's a good one to look at. 3 minus negative 6 squared. Notice my attention to detail is far higher than your attention to detail. And negative 6 squared is 36. So I get 3 minus 36 is negative 36. Questions on numbers 18 or 19? Questions on numbers 18 or?
Oh, so we're trying
Now these kind of asking about 18, so we can look at it. So 30 plus 90 plus 60, and then this is a 90, so that has to be 30. 30 plus 95 plus 50. Because 30 plus 60 plus 90 is 180. How do you solve number 19? Since no one asked about it. How do you solve it? Mediva? James? No, they're proportions, they're not congruency. The reason you know that is because 14 and 63 are not the same number. If they're not the same number, you can't set them equal. So I do 14 over 63 equals 2x minus 16 over 36. Remember, there are lots of correct ways to write your proportions, lots of incorrect ways to write your proportions. Notice that my 14 and 63 are together, and my 14 and 2x minus 16 are together. Those are the rules. They have to be together. As long as you do this right, everything else is pre-algebra work. I would, if I were doing this problem, reduce that so it's easier. And then multiply 14 times 18 and get 256 probably equals 63 times x minus 8, 252. All right, now looking at this red equation here, what does a smart math student do to solve it? There's definitely a better way. Catherine? Okay. There's definitely a smarter way to solve this, an easier way to solve it, than what a lot of you were taught by like your 5th grade math teacher. And it's a shame. So you were told to distribute the 63. It makes so much more sense to divide both sides by 63. So x equals 12. It saves you lots of time. All right? What? Yes. How to get to the red? 14 times 18 is 252. 63 times x minus 8 is 63 times x minus 8. Yep. Now, it doesn't say run a two-column proof, it just says to prove. To prove means you have to explain your reasoning. Richard, explain. Yep. I'll give you that I have a leg. How can I state the hypotenuse side are congruent? Failure? The reflexive property. At some point, Richard, you have to state the reflexive property to prove it. You can say the hypotenuses are congruent by the reflexive property, there are marked legs congruent, so the triangles are congruent by the hypotenuse legs. You can do a two-column proof, where you give these letters, you call these AB, and you can say that AB is congruent to AB by the reflexive property, the triangles are congruent. How can we state, or what can we do to state that these two triangles are similar? What do we need to mark to be able to state they are similar, and why can we mark them? Yes, fine. We have vertical angles right here. What does that give me now? What similarity postulate can I now use? Comparison? I can use angle to prove those triangles are similar. Nope. Similar, congruent has same size and same shape. Similarity has different size, same shape. I have 4 more problems for us to do, so just find a blank spot on your paper. Yeah, because it's blocking the motion. Okay. Let's do number 2, 3, 4. Number 1 is probably not a reasonable. So we are going to know. We only deal with the top. Alright, so we're going to solve these the only way I've solved them all year, because I think it's a better way to solve them. If you build factor trees, you build factor trees, that's what I'm going to do. So here, I get 8 times something times something times the square root of m times the square root of n to the 4th. Now, I need 2 numbers that multiply to 72, and one of them has to be a perfect square. There's a better answer, yeah. 2 and 36. You want to choose the biggest one, so you only have to do it once. Alright, so here, I get 8 times 6. I can't do anything with that. I can't do anything with that. What's the square root of n plus 4? Square root of n plus 4. N to the second. Whatever I box goes back under. Now I just multiply everything together. I get 48 n squared times the square root of 2. We're going to do number 3 up here. I get 2 times something times something times a cubed times b. What can I break 8 down into by something times something? For me, that's something how I always do it, but it doesn't matter. So now I get 2. The square root of 4 is 2. can't do anything here, so I'll box it. I have 3. How many groups of 2 are there in 3? 1. So this becomes A times the square root of A. I have B cubed. How many groups of 2 are there in 3? It's like it's a trick question. It's not a trick question. It's 1. So I get 2 times A times B times the square root of 2 times A times B. So I get 4AB times the square root of 2. Number 4. Number 4 started the exact same way. Just write out 5 times the square root of something times the square root of something times the square root of x squared times the square root of. What are you going to break 20 down into? What are you going to break 20? 5 and 4. So I get 5 times 2 times the square root of x squared is x times the square root of 5 times 1. So I get 10x times the square root of. For most of you in your evening, I would spend your time studying for your first and second hour of class. That's you. But the large majority of you in the classroom, I would say maybe 30 minutes a night, take a look at some of your math stuff, maybe do a couple of those quadratics and whatnot. Save most of your studying for Tuesday evening. If you need any worksheets or like that, internet access at home, you can see me during right after school. Well, you still owe me that trig test. So you got. Remember, we just said just as long as you get a 60 on everything, you're gonna be just fine. And you got I think a 61 on your unit trig test too. So and that one's definitely harder than the first one. Okay. So. Yeah. Okay. So the problem here is that 14 has to go with 63. I guess because I look at this and see that this triangle just needs to be rotated 90 degrees this way to make them match. So that's the first thing I do. And we try and make things similar. So I want to rotate this so that way my shapes match up, so I can match up my style. Okay. Yeah.